The successful launch of the Starliner, NASA spacesuits encounter a mysterious leak. The Mars InSight rover readies for the end of its mission. Scientists receive eerie signals from the Voyager 1 probe after a 29-month silence. Starliner triumph. Boeing Starliner crew capsule has achieved a landmark by finally reaching the International Space Station. Despite facing ongoing challenges during its uncrewed orbital test flight, ground teams persevered and achieved a smooth docking at around 8:28 Eastern Daylight Time on Friday, May 22nd. The journey wasn't without its customary technical hiccups, though. During the flight, 4 of the Starliner's thrusters experienced pressure spikes in the thermal coolant loops, along with a glitch in the pivotal docking system. These obstacles kept the ground crew on edge. Initially, 2 of the 12 aft-facing orbital maneuvering and attitude control (OMAC) engines and 2 of the 28 smaller reaction control system thrusters experienced Q-outs. Fortunately, the redundancy of the system mitigated these issues, and engineers have narrowed down the problem's likely sources to 3. A more significant concern was the cooling system, crucial for regulating the capsule's temperature. NASA manager Steve Stitch suggested that the pressure increase might be due to Florida moisture entering the system and causing pressure buildup. Mission Control effectively addressed this by bypassing the radiators of both loops. The most hair-raising challenge occurred during Starliner's second orbital flight test, where software issues led to the test being canceled just before docking. On this subsequent attempt, a backup system for the NASA-designed docking ring posed a problem, causing Starliner to hold position near the docking port of the Harmony module for over an hour. Ground engineers resolved the issue by retracting and re-extending the docking ring. Eventually, Starliner achieved a flawless docking. The capsule will remain at the ISS until late May, conducting various system tests and data collection. Engineers are particularly interested in the vehicle's vision-based electro-optical sensor tracking assembly (VESTA) system, which gathered data on the range and closing speed during docking. This data was collected by a wired dummy named Rosie the Rocketeer, outfitted in a blue Boeing spacesuit, to assess astronaut safety. Furthermore, the ISS crew successfully tested two-way communication systems while Starliner was approaching. Starliner is scheduled to depart the ISS no earlier than May 25th and land in New Mexico using parachutes and airbag cushions. This success brings immense relief to both Boeing and NASA. The space agency has been advocating for an additional vehicle to enhance crew launch redundancy, and Boeing has borne the brunt of contract delays. While both Boeing and SpaceX were awarded service contracts simultaneously, SpaceX's Dragon capsule has been conducting crewed missions since 2020, whereas Starliner faced a 29-month grounding due to technical challenges. The delays reportedly incurred costs exceeding $595 million for Boeing. However, the true heroes of this achievement are Starliner's ground crew. Throughout the flight, the collaborative effort of NASA and Boeing engineers adeptly tackled every problem. From thruster Q-outs to docking ring malfunctions, the success of this orbital flight test was undoubtedly attributed to this dedicated team. With any luck, this marks the conclusion of Starliner's technical woes, allowing NASA to realize the much-desired capsule redundancy alongside Boeing and SpaceX. Share your thoughts about Starliner in the comments. Enigmatic spacesuit leak. NASA has decided to temporarily sideline the Shuttle-era Extravehicular Mobility Unit (EMU) spacesuits due to a perplexing water leak, while an investigation is underway. The latest leak was brought to light by ISS astronaut Matthias Moore during a spacewalk on March 23rd of this year. During this 7-hour spacewalk, Moore observed water collecting in his visor. Although it posed no immediate danger, NASA opted to suspend non-emergency spacewalks until the issue is addressed. Water infiltration is not a novel problem for these suits. In July 2013, ESA astronaut Luca Parmitano experienced a helmet flood that abruptly ended his spacewalk. In microgravity, water forms clumps and adheres to surfaces, including an astronaut's eyes, nose, and mouth. Fortunately, Parmitano emerged unscathed, likely attributed to his composed response as he returned to the station. This incident prompted a comprehensive inquiry, revealing a blockage in a component that allowed water to enter a vent line leading to the helmet. Subsequently, NASA enhanced its suit maintenance procedures, introducing 2 additional steps to detect the leak early. Firstly, a small helmet absorption pad, HAP, was introduced to soak up liquids at the back of the helmet. Secondly, Spacewalking astronauts are now required to report their HAP status during each excursion. These precautions have proven effective in managing the issue. In recent times, no more cases of water intrusion had been observed within the EMAS. However, during Mars walk on March 23rd, a thin layer of watery film, measuring 8 to 10 inches in diameter, appeared on his visor. In response to this, NASA has decided to cancel the 4 spacewalks scheduled for this year to upgrade the ISS's solar systems. Additionally, they plan to send the EMU back to Earth for inspection in July. NASA's EMU suit, in service since 1981, is projected to be used until 2028, though a replacement might be needed sooner, especially with moonwalks on the horizon. Signs are emerging that the end is near for NASA JPL's seismic measuring lander on Mars. The dust has accumulated on its solar arrays to an extent beyond intervention. Present on Mars since November 2018, the InSight lander's 2 solar panels, providing over 10,000 watt-hours per marching day, have been progressively covered with dust. Predictions indicate that by July of this year, the lander might lack the power needed for scientific operations. Back in February, NASA had cautioned that operating the scientific payload of InSight would become unfeasible by May or June, jeopardizing its survivability towards the year's end. When constructing any vehicle, NASA and JPL must navigate difficult choices based on budget and weight limitations. In InSight's case, the emphasis on essential scientific instruments outweighed the provision of tools for cleaning its solar arrays. Despite this, the InSight team has managed to keep the lander operational, partly relying on sporadic Martian winds that help dislodge dirt from the array. Additionally, NASA occasionally directs InSight to deploy its soil collection scoop, a counterintuitive tactic that effectively removes lighter dust as the wind lifts away the heavier regolith. As part of the current strategy, the plan is to sustain the lander's seismic instruments for as long as possible. Other systems will be powered down, and the instrument arm will be moved to a retirement position, focusing the camera on the seismometer. Remarkably successful beyond its intended 1-year mission, InSight recently recorded Mars' most potent quake to date, approximately magnitude 5, even outside known fault zones. NASA considers the possibility of restoring contact with the probe after the winter period when storms might clear the panels. Kathy Zamora Garcia, deputy project manager, states that the Martian environment remains unpredictable. Uncertainty looms over potential developments. Lastly, in a quick update on Voyager 1, the probe exhibits puzzling telemetry. Both Voyager probes now operate within interstellar space, sending data to Earth with a delay of 20 hours and 33 minutes. Although their communication systems work well, Voyager 1 seems confused about its position. Odd data that seems randomly generated or illogical compared to its expected location is being transmitted back. Curiously, Voyager 1's onboard fault protection systems, designed to activate during such issues, have not been triggered. Engineers are investigating this perplexing situation, while the overarching focus for the Voyager mission is to extend the probe's power sources until at least 2025. To achieve this, non-essential systems are being shut down as the probe's power production diminishes by about 4 watts annually. Launched in 1977, Voyager 1 broke through the Oort cloud in 2012 and ventured into interstellar space. Keeping scientific instruments operational in this challenging radiation environment as they move further from Earth is a complex task. Suzanne Dodd, the project manager, states that mysteries like this are expected at this stage of the Voyager mission. She expresses confidence in the team's ability to resolve the issue with the AACS system. Whether the Voyager twins will continue to function until 2025 remains uncertain.